In the name of Allah, the most gracious, the most merciful. Good morning, everyone. Now we are going to deal with our new program for mathematics department in Tabarak Private School with you, teacher Mohammed Albadry, with grade 11 mathematics teachers, and we are going to deal with the lesson of the sum to infinity. And before everything, we have to say big thanks for the chairman, Mr. Yunus Al-Rahbi. Now we are going to start with our new lesson, the sum to infinite.
And our lesson now is a geometric series. And we have to know the difference between the geometric series and the arithmetic series. The geometric series is a series increasing by multiplication and division, but the arithmetic series is a series which have a relation between the terms by addition and subtraction. It's very important to know the difference between them for any geometric series. We have terms, first term, second term, third term, fourth term, till you reach to the last term. The first term is a, the second term is ar, the third term is ar squared, the fourth term is ar power 3, till you reach to the last term, or the general term, a times r power n minus 1. So here, if we focus, we will see that the relation is about a multiplication. A times r, each time we are multiplied by r, each time we are multiplied by r. So all divided by r depends on the case of this series. So to find the general term of geometric series, Tn equals a times r power n minus 1, where a is the value of the first term, and n is the order of the term, and r is the common ratio between any two consecutive terms. Tm plus 1 over Tm is the common ratio. If we divided the second term by the first term, we will have the same ratio if we divided the third term by the second term, and the same if we divided any two consecutive terms. So for exercise 20a, page 356, number 2a. For the given sequence, find the values of the 11th term, the 20 terms, using Tn equals a times r power n minus 1. So for number a here, 5 plus 10 plus 20. For the first time, 5 plus 10 plus 20. Do you have the same difference between the terms? Let's try it. 10 minus 5 equals 5. 20 minus 10 equals 10. So the first difference was 5, and the second difference is 10. So here we have different values. So it is not arithmetic series. So let's try using divide. If we divide 10 by 5, we will have 2. If we divide 20 by 10, we will have 2. So now we have the same quotient, the same ratio. So here we have a geometric series. So now if we start it, we will have a equal 5, r equals 10 over 5, so equals 2, the common ratio. The 11th term equals a times r power n minus 1. A is 5, r is 2, raised to the power of 11 minus 1 equals 5,120. For the 20 terms, the 20th term here is 5 times 2 power 20 minus 1, will be 2,621,444. For exercise 20a, page 356, number 4a. Find the number of the terms of the geometric series. To find it easy now, the same idea of what we studied before in the arithmetic series. If we have the last term, it is the answer key. So for the answer here, we have a equals 2, r equals 4 divided by 2 equals 2, or a divided by 4 equals 2. And the last term which we have it is 512. To find it now, we have to find the number of the terms. We are going to use the general term. Last term equals Now we are going to study the sum of n terms of a geometric series. To find the sum of a geometric series of n terms of a geometric series whose first term is a and its common ratio is r, we can find it using two formulas. The first formula, with the modulus of r over the absolute value of r greater than 1. We have the formula sum of n terms equals a times r power n minus 1 over r minus 1, and when we have the absolute value of r smaller than 1, sum of n terms equals a times 1 minus r power n over 1 minus r. And now we have exercise 20b, page 357, number 5b. Find the sum of nth term starting from the fifth term when r equals 5 to the 15th term with a relation of 4 times 1.5 power r. So here we have the number of terms starting from 5th term to 15th term, and the relation is 4 times 1.5 power r. Here we have a geometric relation because we have variable in the power, not a linear equation like what we studied before. So the number of the terms here will be 15 minus 5 plus 1 equals 11th term. So starting from the 5th term to the 15th term, it will be 11 terms. And if we want to find the value of the first term, we have to substitute in the relation with r equals 5. So when r equals 5, to find the first term, it will be 4 times 1.5 raised to the power 5 equals 30.375 thousandths. And the absolute value of r, which is the absolute value of 1.5, equals 1.5. So now here's the absolute value of the common ratio greater than 1, so we are going to use the formula sum of n terms equals a times r power n minus 1 over r minus 1. So the sum of 11th term equals 30.375 times 1.5 power 11 minus 1 over 1.5 minus 1, and put it in your calculator. It will be sum of 11th term equal 5,193.97. Here to find the sum of the terms using symbol of the sequence. And for the next exercise, find the sum of the first 5 terms of a geometric series whose first term is a, is 2, and the common ratio is 1 over 3, which is r. So now here we have to know the information we have in the exercise. A equals 2, r equals 1/3, and the number of the terms is 5. So the absolute value of r which is the absolute value of 1/3 equals 1/3. So now the absolute value of the common ratio is smaller than 1. That means we have to use the formula of sum of n terms equals a times 1 minus r power n over 1 minus r. So the sum of the 5 terms equals 2 times 1 minus 1/3 power 5 all over 1 minus 1/3. And like what we have, simplify it or find the value using calculator, you will have it sum of 5 terms equals 2.987 thousandths. And now for the last exercise, we have here in a geometric sequence x minus 4 first term, x plus 2 second term, 3x plus 1 third term. Find the sequence. Here we have information that we have a geometric sequence, and we have to find the sequence, so we have to find the value of each term here. But how could we find it? We have to think. Here we have a geometric series, but we don't have numbers. We don't have a, we don't have r. So how could we find the value of a and the value of r? It's easy now to find it using the common ratio, because the common ratio between any two consecutive terms of a geometric series is the same. So second term divided by first term equals third term divided by second term. So we are going to use it. It will be x plus 2 divided by x minus 4 second divided by first equals 3x plus 1 over x plus 2 third divided by second. Cross multiplying here, we will have it 3x plus 1 times x minus 4 equals x plus 2 times x plus 2. When we expand it, we will have it 3x squared minus 11x minus 4 equals x squared plus 4x plus 4. Now collect all of these terms on one side and simplify it. It will be 2x squared minus 15x minus 8 equals to 0. When we factorize it again, we will have it 2x plus 1 times x minus 8. So here we have to solve it. We will have two values. The first value, x equals half. When x equals half, we have a series. We are going to substitute it in the values of x minus 4. It will be negative 9/2. When we substitute in x plus 2, we will have it 3/2. When we substitute in 3x plus 1, we will have it negative half. So the first series, when x equals negative half. And the second, when x equals 8, from where 8? When we solve x minus 8, we will have x equals 8. So when x equals 8, the series is 4, 10, 25. If we substitute in the series x minus 4, 8 minus 4 is 4, and x plus 2, 8 plus 2 is 10, and 3x plus 1, 3 times 8 plus 1 equals 25. And now we finished the geometric series, and I hope you enjoy with our lesson. Thank you for your listening, and see you in next lesson. Bye bye.
Thank you for listening for our explaining, and I hope you enjoy with us. And the homework, you can find it in the model and in your contact number in the WhatsApp and on the model. Thank you very much.